Welcome to the latest episode of KapVista Klips. Today we have Charles from Atombeam. How are you?
Good, good. Atombeam, though.
Atombeam. Sorry, my apologies. Atombeam. I've got a lot of things on my mind at the
You
moment.
do, but I don't want to get that one wrong.
Yeah, don't want to get that one wrong. But you know this is a company that I was introduced to a few weeks ago by a good friend of both of ours, one of the most well-connected people that I have ever met, and he said, Charles is in Sydney. You've got to go meet him. So I did. And when I sat down with you, I was blown away within minutes. And it's one of the companies that you come across, once in a lifetime. You think, okay, wow, this is really, really big.
Yeah.
So I want to get into it. But firstly, I want to know about you. Tell us about your story. How did you get to this point? What's your background?
Sure.
What made you decide this is it?
Yeah, sure. So I have. It's not a straight line, just to be clear. I'm in the U.S. obviously, and I grew up in the Northeast, born in Newport, Rhode Island, and but I ended up like going into the U.S. Navy as a Navy intelligence officer. And after that, I came out. I went to Stanford. I got an MBA, and then I worked on Wall Street, like many of us did in those days, and still do to an extent. But I got pretty tired of just moving money around, and I like deals, but it needs to have more meat to it. And so I started to get into the management side and worked for a technology company where I was an EVP. Then I was COO of sort of a financial services, in technology operation in New York, pretty big operation. And after that, I became a CEO, and I've had a couple of gigs as CEO prior to this. Um, some sort of tech and some sort of other things, but the fundamentals of how you manage a company, a lot of them are the same. There are a lot of things that you really need to know about a technology or whatever it is you're doing, and you certainly there are domains where forget it. But I'm pretty confident when it comes to tech. And when I came across this, I just said, I got to do this. This is like this changes the world. But there you go.
Yeah. So tell us about the tech, because when you explained it to me when we met in Sydney last week, within 5 minutes I was like, wow, because I understood the importance of what you're doing. I understood how something like what you built can ch- change the world.
Everything. Yeah. It
Yeah,
does. And
yeah,
in with the processor.
yeah,
And that's a wild part of this. So, and it's all based on the idea that from the beginning of digital computers back in the 30s, the way data works and the way everybody's always thought of it is here's a representation of letters, numbers, words, time, date, whatever, translated into binary. That's how it's always been. And but you got to think about what we're doing here because fundamentally that's based on the assumption that everything that computers do has to have the same set of context and repetition and all the other stuff that humans need to understand something. They don't need that. It's not a natural fit. What we can do is take it what we do is we take all the same information and we pack it down into a far more informationally dense package of data so that when a computer does its thing on it or a network sends it somewhere, it's sending the same information. Everything gets there exactly as it was, but it's getting there in a much, much more compact form so that typically we can quadruple the speed of a network we can quadruple the amount of data that a processor is munching on. You name it, about 4 times on average more information gets packed into one chunk than could be before. And that's because we've rethought how data works. The history is everybody thinks, how do you get a faster computer? You make faster chips, you make faster RAM, you make faster networks, you make all that stuff. But nobody has really thought about it from the other end, which is like turn the telescope around and think of it the other way, which is what about the data itself and how it's
Mm.
structured? And that's what we've done that's fundamentally changed it. It's rethinking how data works in everything. And that's why it's such a gigantic potential impact here. It changes the world. How every freaking thing on the planet works can be different and better and faster. And it's not a minor point. It also adds a lot of security. Security obviously is a huge deal. And our focus right now is IoT, the Internet of Things. Any machine that generates data and sends it somewhere, that's an IoT. So what we do is the way we do it as a side benefit, it makes that data far more secure. And 98% of IoT devices have no security to it. They just send out whatever it is and it goes there. And that's going to be a big, big problem. It's already a big problem. But you think about people taking over a car, some hacker taking over your
Mhm.
car, somebody taking over an airplane. All these things are going to start to happen. And people are going to start to freak out about it. And they should, because there needs to be a lot better security. And there also needs to be a lot more efficiency in data. And so we answer everything with one super efficient, super fast little application. It's
Yeah,
a
yeah,
rethink.
yeah. And what you were saying that that what was the numbers in 2025? The amount of data that would be
Yeah, the amount of
produced.
IoT data in
Yep.
2025, according to IDC, 90 zettabytes. And if 1 zettabyte, if you take every byte and call it and say, okay, every byte in that zettabyte is a grain of sand, a grain of rice, it will fill up the entire Pacific Ocean. Zettabytes are gigantic; they're enormous, and put it this way, the entire capacity of all the internet on the planet that can be devoted to non-video, that is say about 30 40 about 20 30% of it. Put it this way, 70 80% of the internet is video mostly, and then the rest of it that is left over gets things like IoT and that kind of thing, email, etc. Those, if you the entire capacity for an entire year is to send about 1 zettabyte. And if you say, okay, I'm going to generate 90 in IoT, and that's just IoT, that's not email, all this stuff, and I can send one of those, and it's actually a lot less because everything else has to go too. And you add it all up, it's like, well, what happens? Where does it? What happens? It gets tossed out, is what happens, and there's a lot of frustration. How do you deal with that? You don't deal with it only by increasing the speed of networks. You do in part, but you also have to rethink what it is you're actually sending to make it smaller. And you can't just compress it, because the big thing with compression is once you've done that, yes, it's informationally dense, but you can't use it. You can't use it in the sense that you can search it. You can't access it. You can't read it. You can't do anything until you decompress it. The cool thing about our stuff, our NeurPack technology, is it's readable, accessible, searchable, you name it, in any amount you want in a giant data lake. And that changes everything.
Yeah, which brings up an interesting point, right? Because you're saying that 90 zettabytes of data is going to be produced in 2025, and only 1 zettabyte of data is able to be stored, right? So where
Same,
does all the
same.
rest
It's less than
sent?
that sort, a lot less than that you could
Yeah.
sort.
So where does it all go? And then thinking about how this works, the power consumption for the servers, the internet is going through the roof astronomically. Like I read a report that the greatest impact to the planet, people looking at global warming and impacts on the planet, is AI
Yeah.
and
Yes. Absolutely. And so that brings us up to the other part. So we actually have three products. One product is the one I've already described, which is NURPAC, which is basically losslessly reducing the size of data and then losslessly reproducing it. But we have another technology we call NURCOM, and that's focused on doing the same thing for video, audio, images, that kind of stuff. Those are both under contracts to the Air Force, the U.S. Air Force, the U.S. Space Force are both working with us on. We have $1.2 million contracts in each case. In each case, they want to figure out how they can adopt this technology. But when you draw it back a little more and you'd say, what is the fundamental here that we bring to the table that means that you can use all that data super effectively? And that is what we call the lightweight code word model. It's really an advance on the LLMs that you read about out there because it's based on code words. And code words, instead of language, are smaller. And that brings us to the first advantage of it. Because it's based on code words in its core, it changes how much time you need to train a model. Big LLMs like ChatGPT can take 5, 6 months to train, suck up huge amounts of power, which is what you're talking about. If you're
yeah,
code based, you're talking about starting with informationally dense data. And if you start there and you push that into the lightweight code word model, it's starting at a point that's way down the road compared to where LLMs start. LLMs have to start out here with language and then go
yeah,
down through the layers. In our case, we're starting way in here because the information is so much denser, which means less training time, as much as 50% less training time. And when another big point of it is because it's informationally dense, it's well, it not only it is informationally dense, it is also able to the code words can represent anything, can represent numbers and time and things like that. Whereas large language models are based on language, and so they'll describe a time, but they can't really do what you know, they can't natively, in the
mm,
core of it, use numbers. And so what we do instead is we natively use those numbers, like in time series data that IoT generates. That gives the LCM, our model, the opportunity to train itself because it has a sense of time. It can autonomously learn. And we haven't proven this yet, but it's at early stage with that. But that really looks to be the probable outcome. And so our stuff can be a, I mean, this could literally be the new thing, the new LLM. And it is able to access the data that is produced by NERCOM and NERPAC and suck that in and use it instead of using the original data. And that can this could change the world. It's how you I mean, one of the biggest issues that CIOs have everywhere is how do I use all this data I have in these giant data lakes? It's very hard to get to. It's all compressed. Can't read it, can't find it, can't do anything. So what do? It's if it's all in NERPAC and NERCOM, it's accessible, readable, usable, and the LCM is how you do that super efficiently.
yeah. So, and I want to put this. I won't say any company names, but thinking about real world use cases. Think of internet companies, server companies, telecommunications companies. Think about what your technology could do for them,
Sure.
right? it could make them faster, more efficient, more access to data, and cheaper to run. It could reduce their operating costs by, in some cases, billions.
No,
Right?
yeah. Well, think of like take NERCOM. NERCOM
Mhm.
gets as much as twice as many images, two and a half as some tops would reach, but typically
Yeah,
two times more images through a given pipe, which means, and that includes video and that includes audio. So if you're say you're a telco, you're
mhm.
AT&T, you're, your Vodafone, whatever, and suddenly you can put twice as much data through your system through. I mean, that would be interesting. You
Yeah,
think, right? I mean, we haven't completed work on that. The Air Force is pushing us very hard. That's an intense, like, really, it's generative. It's not generative AI. It's a neural net AI plugged into a video codec. And by the way, I should mention this too. We have 52 issued and allowed patents, so we have another 66 pending. So we're not kidding around. We've never missed on any patents. Every single one we've ever asked for has been granted. And so this is really original thinking. We have several geniuses, so I don't count myself, just to be clear,
mhm.
but we have several geniuses who come up with this stuff, and it's incredible. It changes. It's like you started out. If if we are able to execute, it's execution. It's not coming up with a groundbreaking new thing because we already did that. It's not protecting it. We already did that. It's coming. It's productizing stuff. It's putting
Yeah,
code into chips, and the chips is how we're going to get to billions of things.
yeah. Again, the chip example just there, making the chips work faster, is speeding up. This is the more and more we move to be dependent on technology, and the more that technology advances, this is going to make our lives faster, better. It's just a game changer. So, tell us about the momentum that you've got. You said you're working with the military.
Yeah. So we have a million two contract with the U.S. Air Force to work on NERCOM, specifically with the Air Force Research Laboratory. And their specific interest is in these very specialized kinds of images like synthetic aperture radar images and hyperspectral images and so forth. But the same basic idea applies irrespective of whether you're talking about an image that was generated by this gadget or a video out of your phone. It's all the same thing to this algorithm. But we're being paid to work on synthetic aperture radar images, so that's what we do. And then the space, I'm sorry, yeah, the Space Force one is with the Space Development Agency. They are launching a series of satellites they call the tranche satellites. Those are intended to support tactical operations of U.S. and other allied nations to support their operations using satellites for tactical communications. They badly need more bandwidth. It's a huge issue. And so, one of the companies where we do work a lot with is Lockheed Martin. They are one of the they're one of the two companies that are Lockheed Space actually is one of the companies that is providing work to the DoD for that, specifically the Space Force. We also have partnership with Viasat, and they're really interested. If you think about the situation, if you're a geosynchronous provider, operator, and you're thinking about, okay, I have 30 satellites or something, how do I, and each satellite's $500 million, how do I make those satellites more efficient? How do I get them to send more data through what they are right now? Because I can't set up a repairman to put in a new gadget, right? That's not going to work. So I got to get them to be more efficient. So Viasat, very big supporter of ours. We also have partnerships with HPE, Hewlett Packard Enterprise, NVIDIA, Intel, You know, we've worked with Saab. We've worked with a lot of big companies, and the number of big companies that are standing by. We just get calls over the transom from the giant oil companies, giant car companies, you name it. Everybody needs to send more data from here to there. And how do I do it? And I can't use compression because it slows it down. I've got to get some other approach. And so we are as soon as we have, like, we're testing right now with multiple smaller companies because we don't want to start with Chevron or something. We want to start with a smaller company. We start with, and we're doing those pilots. As soon as it gets blessed and we fire the gun, then we're off to the races because there's no end of big companies that want to adopt us.
Yeah, yeah. And then let's get into your raising capital. How much you're raising? What's being used for? And then
Right,
what does the next 12 months look like?
right. So right now we're raising 20 million. Um, we are doing it in two ways. One is we have a crowdfunding campaign underway. Um, it is on currently on Start Engine. We may, use other platforms as well, but for right now, it's on Start Engine. It's called the Reg A Plus. It allows us to raise pretty much as we want, and the that raise started off faster than any raise of crowdfunding in the history of crowdfunding, and we went to 4 million inside of 2 weeks. And we also were going to do a Reg D, which is just more or less a private placement. And
Yeah,
it'll have some advantages. If somebody also wanted to come to us with, a large amount and wanted to negotiate something, we'd negotiate it. We only have our capital structure is extremely simple. We have some converts that are about to convert. Then we also have, but everything else is just common stock. So we're endeavoring to try to keep it really simple because we think that we can raise what we need. Um, we have a lot of interest from a lot of folks, and it's because they see what this can be. When especially the more technical people, when they really dig in and understand the implications, then those are the ones are I like it that our most enthusiastic supporters are the people that are the most technical, because they understand the implications. So that's the net of it. I mean, the target is 20 million. The uses of it, mostly just to continue to develop the software, productize it, build out the rest of NERCOM, work on the LCM to take it from its current state. We're going to have to prototype it and all that. It's just hiring people to do that kind of thing, as well as some marketing and sales. But once we have this thing up and running, then we're just going to be taking orders. I mean,
yeah,
that's how I see it.
yeah. All right. I'm not going to take up too much more of your time, but like I said, this is something that I'm really excited about because within 5 minutes of speaking to you, I knew how this could change the world. Now, I see at least 50 deals a week, and I've been in this space for 8 years. And this is, in my opinion, and my opinion only, but I think this is something that will change the world.
I
So,
appreciate that.
yeah,
Let me add one more quick thing. So there's a
yep, yeah,
company that called King's Crowd that rates crowdfunding offerings. We are the highest rated offering ever in the history of King's Crowd. Other than the highest rated company. There was a fund that was slightly higher, but fundamentally, we are the highest rated ever in the history of their rating of Reg A plus offerings.
yeah. Okay, brilliant. Um, Anybody who's interested in learning more, please reach out to my team, and we can connect you directly through to Charles and his team, who would love to jump on um, and chat to you. I think this is something different. Um, yeah, thank you very much for jumping on. This has been incredible.
Yeah, well, thank you very much, Daniel. I really appreciate your having me on.
No problem.
All right.
Thank you.
Bye.